Hi, 7th grade. Today we're working on section 9 of chapter 1, irrational numbers and square roots. Okay? Live tomorrow. 1 o'clock. Be there. All right. Today we're going to start with irrational numbers. Irrational numbers is a number that cannot be written in the form of a fraction, where a can be any integer, positive, negative, and b cannot be 0. Okay? So I know I pre-wrote this and you probably need to pause it, but don't write a number if this little number sign to you is a hashtag, right? It's a number. If you need to write out the word, write out the word. These are your notes, so they need to make sense to you. If this equal sign with a line through it, it means not equal. To me, that's what it means. But if to you it's unclear or you're not sure what that means, don't write that. Write not equal to, okay? All right, square roots. We're going to talk about perfect squares before we get to square roots. And a perfect square is the answer. So it's the product of rational numbers when multiplied by itself. So the first perfect square is 1, because 1 times 1 equals 1. And the second perfect square is 4, because 2 times 2, the same number, times itself, equals 4. And then the next one, I hope now you're catching on, okay? 9, 16, 25, we're going to write those soon. But perfect square is the answer. If you want to write that, right? Answer. Write yourself a note if it's going to help. Product means answer. A square root is the value when multiplied by itself gives that perfect square, okay? And the symbol of square root is kind of like a division sign, right? Like the box, but you have this extra tail. And sometimes like on a calculator or a computer, it has a 2. Because you can also do cube roots, which has a 3. And we're going to get to that tomorrow. All right, so a list of our perfect squares. We don't need these yet, but they might be helpful. So we're just going to make sure we've got them. I was trying to get them all on, but it looks like the camera might be a little close. I'm going to try and back it up a little bit. I think I'm on there now. So perfect squares, 1 all the way to 13, right? So 4, 9, 16, 12, these are all just doubles. These are our double facts, and they're all called perfect squares. Which that leads us to square roots, the opposite, right? These are the problems. So when we have a 4, which is a perfect square, we want to think what times itself equals that number. So 2 times 2 equals 4. But also, because we're in 7th grade and we're working with integers, -2 times -2 equals positive 4, right? Because when the signs are the same, our answer is positive. So the answer to this, if this was a, to the square root of 4 is 2 and -2. These are the roots. Let's do another one. The square root of 25, this is b. The answer, what times itself goes into 25, is 5, right? 5 times 5 equals 25. But also, -5 times -5 equals positive 25. So our roots here are 5 and -5. Okay. All right, C. Let's say this is C. The square root of 4 over 49. We take them each as a numerator and a denominator separately. So just focus on the top and the bottom. Okay? So if we're trying to get our numerator, which we've already solved for 4, that was 2 or -2. And 49, what times itself equals 49? 7. 7 times 7 is 49. But because of the way integers work, it can also be -2 over 7. Okay, both of these are the answers. And the negative can go here, it can go in the middle, it could even go with the 7. We just want one of them, one negative, somewhere on that second fraction. Okay? Okay. Estimate the value of the square root of 28. So we already have our perfect squares up here, right? And the closest ones to 28 are 25 and then 36, right? And 28 is somewhere in the middle. The square root of 28 should be between them. 28 is not a perfect square, so that means we're going to have to round it, which is why the directions say estimate. So 25 square root, we already got, is 5. We're talking positives. Anytime they're going to ask you to estimate, we're talking positives only. So we're going to pull the positive, which was 5. And we haven't done the square root of 36, but what times itself equals 36? I hope you said 6. So 28 is going to be between 5 and 6, which means it's going to be between somewhere in between. So we're going to have 5 point, right? So we need to decide, is 28 closer to 25 or is it closer to 36? So, you know, shoot, use your fingers, right? 25, 26, 27, 28. It's 3 away from 25. Now, if I count from 28 to 36, that's 8. So it's way closer to 25. How are we going to represent that with a decimal? If it's much closer to 25, if it's much closer to the 5 than it is the 6. Are you thinking in your head? I hope you are. I mean, this is a guess type of situation, so there's not going to be a super wrong, well, there is going to be a super wrong answer, but there might be a couple of close, acceptable answers. So I would say 0.3, because it was about 3 away, right? So 0.3. It won't always be like that. 5.2 would be an acceptable answer, but 5.5 would not be, because 28 is not directly in the middle of 5 and 25 and 36. Does that make sense? Let's try one more, okay? Let's try one more. Let's say estimate the value of, how about 38, the square root of 38. Okay? So this is, just want to separate these so we know we did a second one. So if we check our squares, we're talking 36. So the square root of 36, that's one of our squares. And then the next one would be 49. Okay? So 6 times 6 is our first one. And then 7 times 7 is our last one. And the square root of 38 should be somewhere in between 6 and 7. So it's going to be 6 point something. So we have to decide, is 38 closer to 36 or closer to 49? I hope you said 36, because it's only 2 away. And it's 11 away from 49, okay? So my guess would be 6.1 or 6.2. These would be the acceptable answers, okay? So again, if it was 6.5, if that's what you put because it's between those two, that would be wrong, because that's not. 38 is not directly in the middle. Okay, if you guys need more examples or aren't quite sure, come see me or at an office hours, or send me an email, okay, so we can talk it out. Here's the next example. We've got 2 more things I want to go over. Okay, 2 more things. Which is greater, the square root of 18 or 4.4? Okay, so this is another type of question you're going to see in your homework. Which is greater? So you're going to compare these two, the square root of 18 or 4.4. So this kind of gives you a clue that the square root is probably of 18 is close to 4.4. But we have to determine, using estimation, what it exactly is, right? So using the same method that we did for the last one, 16 is close, right? The square root of 16, which is 4. And then 17, oops, not 17, 4, the next one would be 5, right, which is 25. So we've got the square root of 25, and that's 5. So we know it's going to be 4 point something, probably something close to 4.4, but we have to determine what that is. So 16 is 2 away from 18, and 25 is 7 away. So it's closer to 16. So my guess would be 4.2. 4.2. So that would be less. Which is greater? The square root of 18, which I'm estimating is 4.2, or 4.4. Well, 4.4. Based on my estimation, 4.4 is greater. Okay. The last thing I want to talk about, I want to show you, is when a negative is on the outside.